In this lesson, you're going to learn how to solve a quadratic equation by factoring out the greatest common factor of the terms first. Let's take a look at what some of these problems might look like. If you look at this quadratic equation, y equals x squared minus 4x, we're going to go ahead and find the x-intercepts for this particular equation by factoring out the greatest common factor of the x squared and the negative 4x. So another way to write this is x squared minus 4x equals 0. You use the y instead of the 0 when you're actually graphing. Otherwise, it doesn't matter whether you have the y or the 0. So to solve it, we really want to have the 0. So you've learned how to factor out the greatest common factor of just the x squared minus 4x in a previous lesson. So you're going to apply that knowledge to actually solve this problem. So you'll start out the same as if the 0 were not there. You'd look for the greatest common factor of the x and the 4 of the x squared and the 4x. Now there is no greatest common factor of the coefficients, the 1 and the 4, but for the x's, the greatest common factor would just be x, because they both share an x in common. So the greatest common factor, or the x, will come outside of the quadratic, and then you will divide or simplify it to see what's left on the inside. So we will subtract the exponents of the x's, giving us an x minus 4 on the inside equals 0. Now, if you were to distribute this x back to the terms in parentheses, you should be able to get right back to x squared minus 4. Once you factor out the GCF, you're going to go one step further to actually solve it. So to solve it, what we're going to do is I'm going to draw a line between the x and the x minus 4. And I'm going to create two equations, one with the x and one with the x minus 4. So the one with the x, I'm just going to put the x and set it equal to 0. And what the nice thing about that one is it's already solved. X equals 0, which means 0 is one of the possible solutions, or you could say it as it's one of the x-intercepts. To find our second x-intercept, we're going to take the x minus 4 and set that equal to 0 as well. But we're going to actually have to solve this for x. And we get x equals 4, which will be our second x-intercept. So those are our solutions to the quadratic. Now, if we wanted to actually graph the information, up at the top here, I give you the vertex. The vertex is at 2, negative 4, which is right here on the graph. Now, if we actually graphed the two x-intercepts, one of the x-intercepts is at 0, and the other one is at 4. If you look at the 3 points, you can see the parabola forming. So if we just wanted to sketch it, it would look something like this. And that would be a sketch of the quadratic. So again, by solving it, we're able to find the x-intercepts, which are called the solutions. Now you use this form of what we call factoring to solve a quadratic when you only have an a and a b term. So remember, a is the number in front of x squared, b is the number in front of x, and c is the constant, which we don't have in this particular quadratic formula. So whenever you have only an a and a b term and no c term, you have to factor out the greatest common factor in order to solve it. Let's look at another problem. Again, looking back at standard form of a quadratic equation, you have ax squared plus bx, plus c equals 0. So notice again, we only have an a and a b term in this particular quadratic equation. So what we're going to do is look to factor out the GCF of the a squared and the negative 6a. Once again, in this problem, there's no GCF of the coefficients, only of the variables, and they both share an a in common. So that a will drop down and go in front of our parentheses. We will then subtract the exponents of our variables, and we would have an a left for the first term, and then a 6 left for the second term. From here, we're going to create two equations, so we have two x-intercepts. One of our equations will come from the a, and that will just be 0. So one of our x-intercepts is 0, and the other one we will get by solving our other equation for a. Now a is no different than x. It's just another variable that we use, but it means the same thing. So our two x-intercepts, if we were to graph it, we would put 2 points, one at 0 and one at 6. Okay, in this next problem, again, you only have an a term and a b term, no constant. So we're going to factor out the greatest common factor. This time, we have two coefficients, a 5 and a 25. And their greatest common factor is 5. In other words, it's the largest number that divides into both. And for the x's, they both share an x in common. So our greatest common factor will come to the outside of the parentheses, and then we will divide the terms to get the remainder. So our 5's will cancel in the first term, and if we subtract the exponents of our variables, we get an x. In the next one, 25 divided by 5 is 5, and the x's will cancel. Now we will take our 5x and create one equation, so 5x equals 0, and then our x minus 5 and set that equal to 0 to create a second equation. Now whenever you only have an a and a b in a quadratic equation like we do in these examples, and you're factoring out the GCF, one of your x-intercepts should always be 0. So you'll notice here when we divide by 5, 0 divided by 5 is 0. Our second one, if we add 5 to both sides, is 5. So our two solutions, or x-intercepts, are 0 and 5. In our next problem, we have 4x squared equals 8x. We want to write this in standard form, which would be the ax squared plus bx plus c equals 0. So in other words, all of our terms need to be on the left side of the equal sign. So we need to move this over there. Sorry about that brief interruption. Okay, so if we want to move the 8x over there, we're going to subtract it from the right side and move it over to the left. So then we'll put it in standard form. So it'll be 4x squared will stay first, and then the b term, or negative 8x, will be second. We don't have a c term, so at this point we can just set it equal to 0. Now we can go ahead and factor out the greatest common factor. So we would factor out a 4 from the 4 and 8 because it's the largest number that divides into both. And then factor out an x because they both share an x in common. I'm going to move my problem up here. So the GCF would be 4x, so that will come to the outside. The 4's will cancel, and we will subtract the exponents of the x's, leaving you with an x for the first term. We will then divide the 8 and 4, giving you 2, and cancel out the x's. And the 4x and the x minus 2 will now be used to create our two equations. So we know that one of our answers should be 0. So when we divide by 4, 0 divided by 4 is 0. That's one x-intercept. And then if we add 2, our other x-intercept is a positive 2. Okay, in this problem, it's already set up in standard form. The a and the b are on the same side of the equal sign. So if you think about it, what number goes into both 16 and 2? It would be 2. And they both share an x in common. So the greatest common factor is 2x. So we'll pull that to the outside. When we divide, we'll have 8x left for our first term. And notice how both the 2's and the x's cancel. When that happens, you can't just leave it blank, because technically 2x divided by 2x, or anything divided by itself, is a 1. So you do need to fill that in with a 1. Now we can go and separate our problem into two equations. So we will have 2x equals 0, and then 8x minus 1 equals 0. Again, one of our answers will be 0. The other one this time we're actually going to get a fraction. So we'll have 8x equals 1. Then when we divide by 8, x equals 1/8. And that's okay to get a fraction. If you were to graph this x-intercept, it would just be slightly to the right of 0 on the x-axis. Okay, so this one, like when we saw earlier, the a and the b terms need to both be on the left side. So this needs to move over, and we're going to do that by subtracting the 20x to the other side. So we'll have the a term first, which is the 50x squared, then the b term, and there's no c term again, so it's equals 0. When you factor out the greatest common factor, the greatest number that goes into both 50 and 20 is 10, and they both share an x in common. So we will have 5x minus 2x, or excuse me, just 2, because the x's will cancel, equals 0. The 10x will be on the outside. So let's create our two equations, 10x equals 0, and then 5x minus 2 equals 0. So if we divide by 10, x equals 0 is one answer, and then in our second one, we'll have a fraction again. So x equals 2/5, which again is slightly to the right of 0 on the x-axis if you were to actually graph it. In this problem, we have two a's and two b terms, so we need to get our like terms together. So we're just going to move the ones on the right over to the left. We will first do that by subtracting the 2x squared to the other side. And when we combine our like terms, 18 minus 2 will give us 16x squared. We will do the same to the b terms. We will add the 4x over to the left, giving us a positive 8x. So we have the a and the b terms both on the left. We will then factor out the greatest common factor, and the greatest common factor of 16 and 8 is 8. They both share an x in common. So we'll have the 8x on the inside, and when we simplify our individual terms, 16 divided by 8 is 2, and when you subtract the exponents, you get an x. Now, once again, we have this 8x divided by 8x, so rather than canceling both the 8's and x's out, anything divided by itself is 1. So we can now create our two equations. 8x equals 0, and 2x plus 1 equals 0. So the first one, if you divide by 8, your one x-intercept is 0. And for the second one, once you solve it, you should get a fraction, and your second x-intercept is negative 1/2. Now, all of these equations, these quadratic equations, can also be solved using the quadratic formula. So if you've already learned that formula, you could simply plug it in, and you would be able to get the same answer. So for example, if you look back to the previous problem, when it was in standard form, 5x squared minus 20x equals 0, when you're using the quadratic formula, you'd plug in 50 for A, negative 20 for B, and since there's no constant, you'd plug in 0 for C. If you plug those in the quadratic formula and solve that, you would get 0 and 2/5 for your answer as well. So the quadratic formula can be used to solve all of these, regardless of what terms are given for your quadratic equation. And that completes the lesson on solving quadratics by factoring out the greatest common factor.